Hi, this is lesson 2.4, solving multi-step inequalities. This is on page 74. In this lesson, you will learn how to solve multi-step inequalities and how to use a multi-step inequality to solve a real-life problem. Now, this is a great review of lesson 2.2, where we learn how to solve multi-step equations. So I'm going to be repeating things that you heard in chapter 2. So hopefully this is sounding familiar. When you solve a multi-step equation, there's a couple steps. Here's the first step. You are always supposed to simplify each side of the equation first, or in this case, inequality. You solve each side, simplify, I meant to say, simplify each side first. Then use inverse operations to isolate the variable. In other words, we don't want variables on each side. We want to move all the variables to one side. Remember, be sure to reverse your inequality symbol if you are multiplying or dividing by a negative number. We cannot forget that important fact from the lesson 2.3 video. Let's do a couple samples. Let's solve each of these in graphs. So we have y over negative 6 plus 7 is less than 9. First of all, let's think about our onion. Y is the center, the dividing is the next layer, the adding is the last layer. I got to get rid of the adding first. So I'll subtract 7 from each side, which you see here. So plus 7 minus 7 will cancel. And I'll have y over negative 6 is less than 9 minus 7 is 2. Next step, I got to get rid of the divide by negative 6. So I multiply each side by negative 6. Don't forget, you have to reverse the inequality symbol when you multiply by the negative. See, do you notice here how the inequality symbol has reversed? Divide by negative 6 times negative 6 cancels, and y is greater than negative 12. All I need to do is go ahead and graph that. Now I have an open circle at negative 12, and you can see here I'm shading right. Let's look at another one. 2v minus 4 is greater than equal 8. So I wrote the problem. There's my onion. I got to get rid of the minus 4 first. So I'll add 4 to each side first, which makes negative 4 plus 4 cancel, so 2v is greater than equal. 8 plus 4 is 12. Divide each side by 2. You can see that here. 2 divided by 2 cancels. V greater than equal 6 is my solution, and then I can graph it. Closed circle at 6, shading to the right. Why don't you pause the video right now and try numbers 1 and 3. I want you to solve the inequality and then graph it. Okay, I'm back. So for this first question, I wrote it up here. I wrote the inequality. I had to get rid of the minus 1 first, so I added 1. 4b is less than 8. Divide by 4, b is less than 2. I'll graph that in a minute. Over here is number 3. I have to add, I misspoke. I have to get rid of the adding of 11. So I'm subtracting 11 from each side first. So n divided by negative 2 is greater than 1. I'll multiply each side by negative 2. These cancel. N, did you notice how I reversed the inequality symbol? N is less than negative 2. Why did I reverse the inequality? Remember, if you multiply each side or divide each side by a negative, like you see here in green, the inequality's got to reverse. N less than negative 2. Let me graph those. B less than 2. That would be, open circle at 2, shading left. And if I want to graph n less than negative 2, I would have an open circle at negative 2 like you see here and shading left. Let's talk about solving an inequality with variables on both sides. I don't like the work that they put. I don't think they're even following their own directions. Here's the problem. We should write the inequality and simplify it if possible. Let's check. Can I take 6x minus 5 and combine that? No. Can I take 2x plus 11 and combine that? No. Okay, so the first thing we should be worried about, we have variables on each side. I do not want variables on both sides. I want to get them on one side. That's the first issue to take care of. Let's get 2x out of there. Let's take 2x from each side, and I'd have 4x minus 5 is less than 11. Now, if you get to here, there's probably a great chance of you getting this figured out. All I have to do now is add 5 to each side, and 4x would be less than 16, and then I can divide 4 from each side, and x would be less than 4, and there's my solution. Okay? You should always, after simplifying is always step 1. Step 2 is always get variable on one side. Okay? That's an automatic. You should always do it that way. Now remember, when solving an inequality, if you obtain an equivalent inequality that is true, such as -5 less than 0, the solutions of the inequality are all real numbers. Okay? Let me underline that. If you obtain an equivalent inequality that is false, like 3 less than equal -2, the inequality would have no solution. Remember, this is an important, I would get this in your notes. If you start with variables on each side of the equal sign, and maybe I should put here, or inequality, if you have variables on each side of an equal sign or an inequality, this is when you can have no solutions or infinitely many solutions, which in this case would be all real numbers. In other words, anything would work. Okay, so if you go back to the last question I just worked out, do you notice how this problem had variables on each side of the inequality? This is one of those problems where this could happen. You could get no solution, or you could get all reals. In this case, we just got a solution set. X had to be less than 4. All right? So this I would definitely get, stop the video, I would definitely get this stuff in your notes. We have to know that if there's variables on each side of the problem at the beginning, that's when the special scenario can pop up. When you do graph a problem whose solution is all real numbers like they have here, that's a graph that's just completely shaded in as you see in the book. On the other hand, if the problem was no solution, it would just be an empty graph. There would be nothing graphed. Let's look at these two problems and how they solved them. So you notice in this first inequality, I meant to say, we have variables on each side. We got to simplify first. So I'm going to distribute over here, and you can see that they're doing that. 4 times 2b and 4 times 3. That's how they get to here. Do you notice the next step? They're not moving numbers around. They are moving variables. We have to get rid of the 8b, so they take it away from each side. Now when they do that, do you notice in taking away 8b from each side that these cancel? Wow, so do these. We're left with -3 is greater than 12. Let's think about that. Is that true? On a number line? No, -3 is less than 12. That's false. This is a no solution problem. Let's look at the next example. Write the problem down. We have to simplify first, so we are distributing to start. That's where we're getting 10w minus 2 is less than 7 plus 10w. Do you notice the very next thing they do? They immediately take away 10w from each side, which will get all the variables, and oh, wait a minute, all the variables disappeared. We wanted to get all the variables on one side. They all disappeared. We're left with this. -2 is less than equals 7, and that's true. -2 is less than equals 7. So all real numbers are a solution. That means I can plug in any number I want for w, and the left side would always be less than or equal to the right side. I would like you to pause the video and you go ahead. You don't have to graph these. Just try solving 5 through 8. Okay, I'm back. Just to keep the video short, I would suggest you pause the video and quickly check your work versus this for numbers 5, 6, 7, 8, which you tried. Remember, simplify each side first, move the variable to one side of the inequality, and solve it. If you have a question like number 6 where the variables completely cancel, if you have a true statement, the answer is all real numbers. But if you have all the variables vanish and you have a false statement, that's a no solution. So go ahead and pause, check these over, compare them to what you had. If you have questions and you're not sure how I maybe got one of these or whatever, bring that question to class. Let's talk about modeling with mathematics, some of these word questions again. You need a mean score of at least 90 points to advance to the next round. Now think about that. What does the word mean represent? And I hope you're thinking average. So I need an average of at least 90 to advance to the next round. What score in the 5th game will allow you to advance? Let's think. I'm going to be playing 5 games. So my 5 games have to average out to 90 or more. Let me write that down. 5 games, average is greater than equal 90. Okay, so let's write down our 5 games. Here's the games I've had so far. I've had a 95, we've had a 91, we've had a 77, we had an 89, and I have an unknown 5th game. If I take all those scores and add them up and divide by 5, I want that to be greater than or equal to 90. I want a score of at least 90 to move on. Okay? So there is my inequality. So first step, simplify it. I can simplify it by adding all this stuff together, which would give me what you see here, 352 plus x divided by 5 greater than equal 90. So let's think onion. X is the center. I got to do everything on top first, and I would divide after. So I got to get rid of that divide by 5 first. That's why you see in the work, the next step is multiply by 5. So 352 plus x is greater than equal 450. My last step of work, I can now subtract 352 from each side, and it looks like my score has to at least be 98 or more points. Here's a way I could check that. If I want to average 90 points per game over 5 games, 90 times 5 is 450. If these 4 scores plus 98 work out to 450, that would be a pretty good indicator I have the right answer. And if I do add those up, I do get 450. So it's got to be 98 or greater. I got to score at least 98 on that last game to move on. I'm going to stop the video here. If you have any other questions, make sure you ask in class.